So in this video, we have another example of an exact differential equation which involves sine y minus y sine xy dx plus x cosine y minus x sine xy dy, and is equated by 0. So as we learned from our previous video, first we have to identify which is the function that we're going to use in the equation. So first side is the function m of xy, and basically the other side is the function n of xy. And now that we've established each of the function, we can now get or solve for the exactness of the equation. So partial derivation of m in terms of y is equals to cosine y minus, since y sine xy can't be solved in normal means, we'll use product rule. So y open parenthesis d over dy sine xy close parenthesis plus sine xy open parenthesis d over dy multiplied to y close parenthesis, and then cosine y as it is minus y. And since we're deriving from in terms of y, we'll treat x as constant. So d over dy sine multiplied to sine xy will become x cosine xy plus sine xy as it is, and then d over dy multiplied to y will become 1. So our answer will be cosine y minus xy cosine xy minus sine xy, since we just distributed the negative sign to each of the terms. So next is the function n, which will be derived as, oh no, I made a mistake, sorry. So the function n will be partially derived in terms of x. So basically we'll do the same thing as the other part, so we'll use the product rule in solving the x sine xy. So x open parenthesis d over dx multiplied to sine xy close parenthesis plus sine xy open parenthesis d over dx multiplied to x close parenthesis, and then again cosine as it is minus x, and since we're deriving from the in terms of x, we'll treat y as constant, so d over dx sine xy will become y cosine xy plus plus sine xy, and again d over dx times multiplied to x will become 1. So the final answer is cosine y, and we'll distribute the negative to each of the terms, so minus xy cosine xy minus sine xy. And now that we've got the partial derivation of both the function m and the function n in terms of each of their respective derivation, we can now surmise that this is an exact equation. And now that we've established that there is a partial function which is equal to the m function, we can now equate the value in the m function in order to solve for the partial equation. So sine y minus y sine xy will be derived in terms of x. Oh, I forgot to put the dx, sorry, dx. So sine y minus y sine xy dx will be integrated in terms of x. So sine y will become x sine y. And since y sine xy can't be solved in normal means, we'll use the power rule, which is basically will let u is equals to xy and du will be equal to y dx, and lastly dx will be equal to du over y. Now that we've established these terms, we'll put x sine y as it is, and then we'll proceed with our equation. So minus y integration of sine u multiplied to du over y, and again x sine y as it is, and minus y over y integration of sine u multiplied to du. So we're almost at the final part. So again, x sine y plus so integrate sine u, it will become negative cos, so it will become positive cosine u, and we'll add a generic function which is g of y. So to complete our first equation, it will become x sine y plus cosine xy plus the generic function which is g of y. So we've got our first equation. Now that we've got our first equation, we can now derive it in terms of y. So x sine y plus cos xy plus g of y, which is the generic function, will be derived in terms of y. So x sine y will become x cosine y sine y plus, since cos xy again can't be solved in a normal means, we'll derive this, we'll use the derivatives of cos xy using the chain rule. Cos xy using the chain rule. So basically the standard form of the chain rule is f prime of g of y equals to g prime of y. We'll let f of y be cosine y, and we'll let the g of y be xy. So d over dy multiplied to cosine xy, which is then multiplied by d over dy xy. We'll let u be xy. D over du cosine u multiplied to x, which will result in negative sine u multiplied to x, which will procure the answer, which is negative x sine u negative x sine u, which is substituted by xy. So we had the derivation of cosine xy in terms of y. I'll just erase some of these parts. And now the plus sign plus negative x sine xy plus the generic function, which will become g prime of y. So x cos y, distribute the negative, so x sine xy plus g prime of y. Now, using this equation, we can now cancel out the like terms using the function of n, which is x cos y minus x sine y, x sine xy. Oh, let me erase. I think I got the boundary of the whiteboard. X sine xy. Cancel out x cos y and cancel out x sine y, which will give us the value of g prime y equals to, since we cancel them out, 0, and to integrate g prime of y will result to g of y, which is equal to c, since if the g of y is 0, we'll change it to our arbitrary constant, which is c. So using the first equation, x sine y plus cos xy plus g of y, will substitute the generic function to c equals to 0. So our final answer will be x sine y plus cos xy equals to c. Thank you for watching. I hope to see you next time.